This year's exciting news in KotlinConf is that they are working on the stability and best practices. And this is why also I'm talking for you in here. Welcome to Efficient Kotlin. In this presentation, we are going to talk how to make your project better in terms of performance and in terms of memory use. This presentation is based on my book, Effective Kotlin. A book has 3 parts, covers practically all the important best practices. Parts are separated into chapters, and in this presentation we are going to talk about the 3rd part, the efficiency. So, make it cheap, general best practices for performance. And let's start with something, before we start with that, I would like to talk about a very basic abstraction we use every day, that is the object. So object, the most basic abstraction, the most basic building block in the object-oriented programming. Though when we use objects, we should be aware of some costs what are their costs. So let's start with something simple. Creating object, even an empty one, costs something. Yeah, it requires some space in the memory to allocate that. Who knows how much is that? Can you just shout? 4. It's a little bit more. It's not necessarily true. Sorry, it's either 8 or 12 bytes. Then it's pad to the multiple of 8. So it's relatively a small number, but if you add to that the memory reference that is additionally 4 or 8, depending on the version and the processor you use, it started having some shape. So if you compare the integer, the primitive, how much an integer primitive take? 4. Stay with me after the presentation, yes, and who can calculate how much will it take to have an integer, the wrap type? Well, so we need, in most implementations, it's 12 bytes for a header, 4 bytes for int inside, so it's 16 bytes plus the reference. This is 5 or 6 times more than the primitive. 5 or 6 times more, this is not trivial. Also, allocating object, even an empty one, takes some time, clearly, but it's even more painful if object has some state. So clearly, whole state needs to be allocated, created. We might have some improvements if we reuse the same objects. We'll get back to that. Another thing is that class holds behavior in methods. Methods are another kind of a boundary. We'll also get back to that. So let's talk about the most basic thing when we think about using those resources efficiently. That is to avoid creating unnecessary objects. And here actually Kotlin gives us a bunch of tools that we can use. One very important is, in the bytecode, in the JVM bytecode, we have some optimizations done under the hood, and even though it might look like very low level, it's actually done in bytecode, it's done in many libraries. So if you create 2 strings, using string literals, they have the same content, it's guaranteed that those are not only inside the same strings, but also the same objects. Also, integer has its own cache. So if you use an integer in a small number, in a close to 0 number, it will be reused. This is kind of an optimization that is used on the JVM under the hood. Many such caches are also in other libraries. By the way, who knows what is the standard limit of this cache, the low and high? Seven, yes, thank you. You also stay with me. And of course, it can be customized, the high can be customized, but it exists. So what tools are given to us by Kotlin? The first and I would say the most basic one is object declaration. So imagine the following pattern. We have a sealed class, so the class that has only two types, subtypes, node and empty. One problem in here is that even though empty do not hold any state, it needs to be created every time. And a very simple improvement that is very popular in Kotlin community is to use object declaration. So object declarations are used very often when we represent a state pattern, when we send messages, and we do not need to hold any data. Notice that in here we had to pass some type parameter, type argument, and on the other side, and the common solution is to make the type parameter of the superclass covariant, that is to use out modifier, and then use nothing on the object declaration. Now, linked list of nothing is a subtype of every linked list, because nothing is a subtype of every type. Very common pattern, very common solution, gives us easier object creation, reusing of this object, and also easier when expression, because you can use referential equality, not type equality. Another common technique is to use factory functions with cache. Another thing that is used widely when we create objects using factory functions, like list of. We do not need to create objects every time. We can reuse the same object. We can return some subtype. And so in the standard library, when you ask for an empty list, there is actually object declaration returned. So one object, one empty list reused everywhere. Although very often we need to pass some parameters, and then we are implementing, the common solution is to have some map that holds key, that is the parameters, and the value, that is the result. A very simple example of that is a Fibonacci cache. So this is the implementation of Fibonacci that is implemented according to the definition, very popular in the functional programming communities. And it achieves high performance, relatively high performance, thanks to the cache it uses. So if you compare the speed of this approach with the speed of iterative approach, clearly it will be slightly slower because you are storing all the values. Although if you ask it for the next time, the answer will be immediate. Getting something from a map in the JVM is practically immediate. So it's very, very efficient. Although, what is the problem in here? Concurrency is one problem, and I ignore that for the sake of simplicity. A different problem. It's, as you can see, not problem in here, because we are reusing and every value is calculated once. Memory. I don't know who said that, so okay, please stay with me. I think this is where the voice came from. So yeah, we can trade performance problems with the memory problems, and we have less performance problems, but now we have out-of-memory exceptions. And a simple solution to that is to use references. So there are two references. First of one, more known, is a weak reference. It does not hold object at all. Very bad idea for a cache. It's like it will be garbage collected every time assuming nothing else, reference that it will be garbage collected every time your garbage collector works. But a better candidate is a soft reference. Formally, it does not guarantee anything, although in most implementations, it garbage collects this object only when you need memory. So it's quite a good candidate for a cache. Although using that is not convenient, but here is an implementation where you can see that the upper part is nearly exactly the same, but I also introduced a delegate that wraps that holds a reference, tries to get the value from the reference. If it is there, it returns it. If it is not there, it creates it, it stores it in the reference, and it returns it. Very, very simple use of property delegation, and yet we have our memory relatively efficient. So it will, if we need more memory, this will be garbage collected, and in the same time, we have it relatively fast, and we have our caching mechanism. Simple thing, but helpful. Another important technique is object lifting. So I hope this part is clear. The problem in here, I'm not even asking, is that when we want to count how many elements are equal to the maximal elements, or how many maximal elements are there. So the problem in here is that we are calculating max for every element. Clearly absurd. It should be lifted and calculated only once. Hope these kind of cases are clear, but there are many, many cases that are not so obvious and are easy to miss. So what is the problem in here? Compile. And why is that wrong? Yeah, so the point is that this regex is quite complicated and it needs to be created. Stay with me, of course. It needs to be calculated every time we call this function, and this is a heavy object, heavy to compute object. It should be lifted, although we moved from one problem to another problem. Can anyone spot this problem pretty quickly? Yeah, so, yeah, sure, stay with me as well. The problem is that, imagine that it's a part of our util files, util file, and there are plenty of such functions. And many of those functions extract something heavy. And so, and all that needs to be initialized statically. And so the first time you use some function from this file, it's like super heavy because it needs to initialize everything. And the common solution to this problem is to wrap it in a lazy, so then it will be calculated on demand. The same technique is used in objects. So if you have object A that has object B, C, and D, and each of them is, let's say, heavy, then object A is super heavy, and it can be simplified if we wrap those in lazy. Then they will be created on demand when they are needed, and we both make A creation much lighter, and hell object probably lighter as well. Another thing is using primitives. It was clear in Java. It is not so clear in Kotlin, as Kotlin do not have a concept of primitive. In general, int is compiled into primitive whenever possible, although it is not always possible. A very simple case where it is not possible is when we have it nullable, okay? Because primitive cannot be null. Also, when it is used as a generic type. And so this is a very minor thing that makes sense rather in like library code, but sometimes we do optimize to use primitives under the hood. So here is an example implementation of max or null. We are setting max to null. We are iterating. If something is bigger than this value, and if it is not present, we use min value, then we are setting this element. Clearly, two problems here. First, we are using integer instead of int. Second, we are using LVS operator in every loop. A better implementation could solve those problems, and this is how it looked like. We need to make our own iteration using iterator. It's a bit more complicated, but it is visibly more efficient. I do not have it on slide. I think from my benchmarks on bigger numbers, it was like 50 or it was like 30 or 40% faster. And this is the implementation that is present in the Kotlin standard library if you take a look at max function. Okay, another thing is a notion of boundary, the functions that are kind of boundaries. So when you call a normal function, like for each in here, when you call it, you need to jump with your execution inside this function, put an address, bulk address in the stack, and etc., etc. There are some actions that needs to be done. So it's kind of a boundary, a very, very small one, but still it needs to be passed. What is more painful in this case is that when we are using this lambda expression, it's another jump and another boundary, and this lambda expression needs to be stored somewhere, so it is stored in a separate class. So it's kind of a boundary, and it started being painful. But when you add some capturing is not supported in JVM by default, so this captured variable needs to be located in some object as well. So there is some object, an int reference or a reference, and every time you use it, you need to pass this boundary. And it started. You can feel that we are wasting quite some time on all those additional jumps and operations. And it can be all simplified. I mean, optimized if we use a simple inline modifier. So inline modifier makes our compiler replace function call during the compilation with its body, and also all the parameter of functional type calls are replaced with their bodies, and so during the compilation time we'll have a for loop and a print. No boundaries, everything is efficient, and yeah, again, a visible improvement if the list of students is not a small list. And so, knowing that, it should be clear that it's good to use inline modifier, especially for function with parameters of functional type. Clearly, it's not the only use of inline modifier. Another thing is a Rayfield type parameter. So in Java, we do not really have generics under the hood in JVM. They are all lost during compilation. They were introduced in like version 5, and they do not exist in the bytecode. And so we are losing a lot of information, and that's why it is impossible to do something like that, to pass type parameter and use it for reflection, for check, for whatever, because we are just losing this type during compilation. Although, if you use inline modifier, then you can make your type parameter Rayfield. It means that during the compilation, during the use, like in here, the type argument int, char, and string will actually, the call will be replaced with body, and type argument will replace its type parameter use. And so thanks to that, we can pass types however we want. Very useful thing. Although we should be also aware of the costs on the inline modifier. It's not a hammer for everything. First of all, inline functions cannot be recursive. And I think it was improved, but when some time ago I had a problem when it was very, very long recursion, so like function A called function B, there's function C and function D, and this called function A. It couldn't be found by the compiler back then, and it was my compiler had a big problem. Another, what is even more important problem is that they cannot expose anything with a more restricted visibility. So if you have an inline function, let's say internal, you cannot use anything that is private because the body will be replaced in the use, and so private cannot be properly used in this outer context. And this is, I think, the biggest pain in general. And the third thing is that they make your function grow. Because of that, inline modifier, perfect for utils, perfect for functional programming in the limited use, although not so good when you define abstractions, when you do methods. One thing that I would like you to know, very important, very simple thing, and yet I often see experienced developers, Kotlin developers not knowing about it, cross-inline and non-inline. Very simple explanation. So cross-inline means that something will be actually injected, it will replace its use. So in here, on refresh will be replaced with the body of the function, although because we are in a context where we cannot in an outer context, so in a lambda that is not going to be inlined, some functionalities, concretely non-local return, are not supported. So practically, on refresh will be inlined, but non-local return not allowed. Non-inline, something won't be inlined at all, so normally property will be created, variable will be created, anonymous class will be created, and it will be passed to another function in here as on generate. Okay, another part starts with a little bit of a history. So some time ago, NASA wanted to send an orbiter to Mars. It was a huge project that costed a lot of money. NASA equipment expected the calculations, the control in the Newton seconds. Although they took external company to implement the software, and there was some problem in the communication because this company made a totally, well-developed and well-tested software that was producing and expecting data in pound-force seconds. And so, as you can guess, whole orbiter just crashed in the Mars atmosphere because the control wasn't working, didn't work at all, and 300 millions of dollars were burned like that because of the mistake in the units of measure. And we actually have this problem every day in the world. So we are having different units of measure everywhere, like clear one like time, but also in the databases, in the graphics, in the artificial intelligence, and also we are, I guess most of us do some front-end development, and we use many of units of measure, pixels, dp, isp, centimeters, millimeters, and it's easy to make mistake here. So let's talk about indicating unit of measure for the sake of safety. So imagine that you are having some interface that expects some time. What is that? I don't know. The first technique that people often do is indicating that in the name. Useful, common, but safety is still very limited. First of all, when you return, it's harder to indicate. Second of all, nothing stops us for making incorrect use. So let's say that decide about time, returns type in seconds, timer expects time in milliseconds. Nothing stops us from misusing type. Of course, the simple solution is to wrap it in the classes that protect us to a certain degree. But now we go into the first item we discussed. We are creating unnecessary objects. And so a simple solution to that, we are having a degree of safety, but yeah, we are creating unnecessary object. A simple solution for that is to use inline classes. So inline classes is a new thing introduced in Kotlin 1.3. When you make inline classes, you need to have only one parameter that you hold, and then during the compilation, whenever you use this inline class, it will be replaced during the compilation with the type of property that you hold. So in this case, name will be replaced with a string. If you have some methods in inline classes, these methods will be invoked as static methods, and the receiver of type string will be passed to them on the first position. And so when we introduce that into our example, we are eating a cake and having a cake. We both have a safety, and we have our code efficient. One annoying thing is creating that object, so creating minutes, creating milliseconds, and for that a useful technique is to make a simple DSL like this one, and notice that if you want to make it even faster, you can make those functions inline as well. Another case where it is very useful, imagine that you need to create some entity, and you have a student ID, teacher ID, and school ID. Again, very easy to make mistake to use student ID as a teacher ID. But what we can do is that we can wrap those into an inline classes. So during compilation, those inline classes will be replaced with an int, so still entity will be processed correctly. And in the same time, and so correct objects will be created in the database, and in the same time, compiler, the typing system, will protect us from misusing those types. Though I would like you to notice that this all works only when you use objects directly. When you use them from behind an interface like time unit in here, then object needs to be created, and so it won't be optimized. So in this case, minutes and millis won't be an int, it will be actually a wrapped type, because if it would be passed to the setup timer, compiler wouldn't know which one you passed. So it only works if you expect actual classes, not an interface. And what is important, type aliases do not give us any degree of safety. So type alias is just an alternative name for a type. So instead of int, I can use new name now. It's very convenient when you have long and complicated types, especially types like a function type with names. It's very, very convenient. Although it does not give us any degree of safety. So here I am returning millis and expecting seconds, but they are all just type aliases to int, and so nothing stops us from misusing them. It's rather confusing than helping. So it's better to not do that. And let's get to the memory. So eliminate object references. Here we will have a little bit of puzzlers again. Who is in here an Android developer? Most of you, so you should be familiar with this problem. Before we get to the problem, we generally do not think about maintaining memory, because this guy does that for us. This is a garbage collector, and we think that, okay, if he works fine, everything is fine. But to a certain degree, we should also think about memory, and especially about leaving objects we do not need anymore, because otherwise we generate a memory leak, so a reference that is not used anymore, and yet still is blocked from being recycled. So let's take a look at this Android example. I would say this is a classic newbie mistake. Many people just store the activity in a companion object in a static field because they want to access it more easily, though this is a huge memory leak, because if we do that, this activity cannot be garbage collected, even when we do not use it at all, because it's still referenced by this static property. And activities are generally heavy, and so it's a terrible mistake for our memory. Although people are already aware of that, and they moved from this kind of mistake to a slightly less visible variant of the same mistake that uses like that. So it's not uncommon for me to see that people store in some weird places, let's say functions, and this function, notice, this function is capturing the reference to the activity. And so activity cannot be garbage collected because this is captured by function, and function is placed in the object, companion object. Okay, so this example is inspired by Effective Java by Joshua Bloch. So who can tell me what's wrong in here? Yeah, Yeah, so of course, stay with me. You definitely know effective Java. You must remember this example because it's a Kotlin variant of that. So what we do in here is that we have an array, and when we push an element, we are really adding it to the array. If we do not have any more space, we are just making our array bigger. But when we are popping element, we are not really removing that. We are just decreasing the size. And so object is still held by the array, but not accessible anymore. And a very simple solution for that is to set null in here. So, okay, it was easy. It is an example you are probably familiar with already. But imagine that you are implementing a lazy property, delegate. So it's your own implementation. Of course, there are many things missing here, like synchronization. But about what I just say, what is the problem in here? Can you speak a little bit louder? Yeah, so this is the answer. Stay with me. Yeah, we are using initializer only once when we are getting value for the first time, and then we do not need it anymore. But we are still holding that. And what is the cost of that? What is kept by this initializer? I don't know. It might be anything, whatever is captured by the lambda expression. So it might be very heavy, I don't know. And so it's better to set this initializer to null, although what is not uncommon, these kind of problems, now notice that initialized and initializer being null, I mean, initialized is always false, where initializer is not null. So we can simplify it and just use initializer not being null as the indicator that the value is not initialized. Okay, another part is efficient collection processing. I hope that you already have some idea how to reuse objects and how to use your memory effectively. I would like to talk a little bit about collection processing, because collection processing is often very expensive and very complicated in many applications. Classically, we did collection processing like that, using a variety of functions like sort and algorithms like you can see filtering in here and mapping in here. In Kotlin and in Java since version 8, we can do that using easy and simple collection processing functions, although those functions also should be used efficiently, and there are some technique we need to learn about. And the first thing I would like to touch is the difference between iterable and sequence. They are very similar to when you look at them from the outside, used in similar way, their definition practically identical, although they have a very different contract, and you should be aware of the way how they are both used. So iterable processing practically always produces the final result after every step. Produces a list in most cases, and so we are just processing everything eagerly, and then we have a result that can be stored, that can be saved, that can be sent, whatever. Sequence, on the other hand, is just decorating the previous sequence with a new operation in all intermediate operations. It does nothing until the last terminal operation that goes outside of a sequence. So sequences, thanks to that, are lazy, and they do everything in the last terminal operation. So when you finally ask for this list asks filter, filter asks map, map asks sequence, sequence returns number, it is mapped, it is filtered, and it is taken, and this is how we do all the processing. Nothing happens in the intermediate operations, only wrapping the previous in the new operations. Everything is going on in the terminal one. There are a few important results of this. So imagine that we do some processing. When you do that using list processing, the order is that we first go through all first elements, then we are mapping all elements. Sorry, first we are filtering all, mapping all, and then calling for each. When we do sequence, very different element by element. We take first element, we filter map for each. Second element, we filter. Third element, we filter map for each. Very different. Which one is more intuitive for us? If we would use it, if you would do it using classic loops, I would say it's practically surely lazy. And this is one thing that stops optimization of Iterable, by the way. So it is not done by under the hood right now, but maybe we'll at some point have optimizations for lazy for sequences that cannot be done for lazy because of the order of operation. Although there is much more important result. So when you process elements eagerly, you need to always process all the elements. When you process them lazily, you do the minimal number of elements. So you can imagine if you end up with something like find, then you have a faster processing. But it is one of the things, minimal number of operations, although because of the way how it's implemented, it can be also infinite. And also, we do not need to create collections at every step. This last one is very important, and I will discuss that more in a moment. But the result of that is also that they are better, they are more efficient for big or heavy collections. So let's take a look at this example. So here we have some file. We read lines. So this is a list. We drop the first one, as those are descriptions. Map to take the seventh column. We filter, and then we count. What is wrong with this implementation? And what might go wrong with that? Out of memory, of course. Imagine that this is a big file, and by the way, this is a big file, over 2 gigabytes of data. And then you have another 2 gigabytes of data, because first you return a list, 2 gigabytes of data. Another list, 2 gigabytes of data. Stay with me. Map, probably a little bit less, filter a little bit less, still a lot of memory that we need to allocate. In my computer, it is out of memory error. Even if it passes, it is terribly slow because of all that huge collection allocation, garbage collecting, cleaning, etc., etc. It's much slower than when you do that correctly. The correct way to do that is to use a sequence. So we have function useLine, and inside we have a sequence, and we can do exactly the same processing, but using sequence processing. So we are always thinking about one line at a time. We never think about more than one line. So that's why sequences are generally better for big collections with more than one processing step. This argument is not true when those are small collections. I define big collections as more or less more than 10,000 of elements. If you have hundreds of elements, this is for me small collection. It's better to use collection processing. They are generally better because they are inlined. They are more convenient because you do not need to go into sequence and then go back to collection. And so in most cases, in the simple case, small case, I prefer list. I choose sequence for big, important files, possibly heavy lists. And I'm not a fan of this. This suggests to convert to sequence always. I am not a fan of that at all. Although what needs to be mentioned is that sequence has additional support that I think does not really work so well right now, but it used to work quite well, and I hope it will. That is sequence debugger. It's built into Kotlin plugin, and so you should be able to see how this sequence is processed, and every step is super convenient. if you to see how your sequence evolves and is calculating the result. Okay, so a few more suggestions. One is to limit the number of operations, and take a look at this problem. We are mapping, we are filtering out nulls, then we are mapping to have not nullable. So what can we do better in here? Yeah, I have a lot of, I think this is very easy. So we have a first one is, instead of filtering out nulls and then mapping, we can just use map not null. And instead of filtering and map not null, we can use map not null. Here are a few suggestions from my side. Honestly, some of them are already, I think one or two might be already suggested by the compiler. When they will all be covered, I will just remove this item. For now, it's worth to know that there are some easier alternatives for common collection processing patterns. And if you see a suggestion like this one applied, it's very useful. Then we were talking about how expensive numbers the wrap types are comparing to the primitives. That does not really make a difference when there are few numbers, but it does make a difference when there are plenty of numbers. And so list with int translates into list with integer, a wrap type, the same array of int. But we can have array with primitives. And because Kotlin does not have a concept of primitive, in Kotlin, for that, we have int array, long array, char array, float array, etc., special types to represent array of primitives. And when you have a lot of such primitives, especially if you do game development, data science library, graphic processing library, it might make a significant difference. So in most implementations, when you have a list with millions of elements, it's over 20 megabytes of data. When you have the same, but as an int array, as an array of primitives, it is 1/5 of that. This is only 4 megabytes of data. So you can guess significant difference if you have a lot of numbers. And also processing of primitives is faster, not so much, but visibly faster. And so when you have a lot of possibly primitives, it's good to consider int array and other array with primitives. And the last suggestion is that in one of the first items of the book, I generally suggest to consider immutable collections because they are easily observable and because we can easier control their state. Although clearly immutable collections are faster, and especially in a local context like in here, when you are inside some function and we fully control how element is changed, so we do not have any problems with synchronization. We do not need to control so much. I mean, we can see how the state changes. It's generally better to use mutable collection. This is just faster, and so practically all the functions in the standard library under the hood, collection processing functions, used mutable collections, but they declare immutable as the return type to not leak mutation. Yeah, so this is an example. And another very small thing I would like to mention, setting size is in Kotlin still a very big thing when we are allocating objects. Okay, and that's everything. I have some time for a question. It is based on the book. For the sake of reference, here are all the items I covered. As far as I know, I also have some books to give on the demo room. This is everything I got for you. Slides will be, as always, on my Twitter. And for now, thank you for your attention, and I will have a time for questions. Thank you.
That was great. Thank you very much, Marcin. Before we get to questions, we need to do the math with the books. So everybody who have been promised, who have been asked to stay, please raise your hand so I will be able to count how many books to put aside. 1, 2, 3, 4, 5, 6, 7, right?
I think so, yeah.
Yeah, okay, right. So the way it's going to work, we have some time for questions now, 15 minutes, and then we will all go to the discussion zones when the remainders of the books will be given on a first come, first served basis, but people who have been promised will get theirs no matter what. Okay? And sounds good?
Great.
All right, and now questions.
Hi, thank you for your presentation. It's awesome. I have one question. Did you calculate which faster, iterable or sequence? Did you calculate which faster?
Which is faster. So yeah, so this is very complicated. So I've actually I did quite a few benchmarks in here. I mean, for this size, it's obvious when it's heavy. It's clearly obvious. But for cases like, I don't know, like this one, it's very, I would say, it's hard to find some pattern, because if this is a really big collection, like really 100,000, it's very, very clearly sequence is faster, but also it very much depends how much. I would say, from my observations, I would guess around 30 to 50%. But if you have a small one, like, I don't know, 100, few hundreds, it's often that classic is faster because it is inlined. So you can see in here, this one is wrapping, this one is inline. So here we have additional cost of allocating objects, but here, but we also, here we have additional cost of allocating objects, but here we have additional cost of creating lambdas. So in many cases are very unclear. So yeah.
Yeah, thank you.
Yeah, but if this is something big, like, I don't know, logs or possibly big data from a database, it's very clearly sequence. If it is something very small, like 10 elements, it is more convenient and generally faster to use iterable.
So thanks for your presentation. That was amazing.
Thank you.
And I wanted to ask you for some technical explanations. Why can't we use reified type parameters at some abstract classes at abstract objects?
So reified, oh my God, I also show some examples in the book because it is very convenient to pass type. So for instance, a few examples maybe. In the Kotlin, since version 1.3, we have a function type of, and then you pass a type. Crazy useful thing when you do reflection a lot. It's just, you know, it's just the easiest way to have a type reference. In many libraries, you are inferring type. So I maybe have some. Is it recorded? Okay, so I won't show, but I have some examples. Imagine that you are having a function read object for a JSON, and you do not need to put class reference. You just read object, and in the diamond you are passing type. And even if it can be inferred from something somewhere else, you don't even specify it at all. So like super convenient for creating object of some type, for getting object of some type, super convenient in libraries. It's very, very commonly used. Okay, I hope I explained.
Thanks for the presentation. I have a question. You had an example with Fibonacci cache, and you use map that used integer as a key. So you can pass primitives to generics, as I understand. So will this example cause overhead due to boxing and unboxing?
That's a good question. So, yeah, it actually does. Though I think it is very, very minor. So, yeah, it does. I don't think that in this case it is minor. This suggestion with object wrapping, I want to make it clear that it can be easily taken to the extreme, like people trying to use primitives instead of wrap type, and in most cases it should not be taken too seriously. I mean, it makes sense in some very intensive cases, and I mean, this code, this kind of optimization, you can see this is much uglier and clearly more complicated. And this kind of optimization totally makes sense if you do some library, or if you do standard library. But in most cases, I think the advantages of simplicity in most projects, and the advantages of simplicity are more important. So I'm kind of worried that people will take these primitives to the extreme. So we should be treating that in the cases where something is very, very intensively used rather. Yeah, I hope that it explained.
More questions? All right, so... yeah, here we go.
Hello. Should I be clear how long it takes for compiler to inline classes, or should I use inline classes wherever it's possible?
Yeah, so it slows a little bit compilation time, but in most cases those are very small differences, and we are generally not. We generally do not treat it as a problem. What is, though, treated as a bigger problem is a problem of growing code if we use a lot that inline function. And I wouldn't mention that if I wouldn't experience that. So I actually made my engineering thesis in functional programming Kotlin, and there was like lots of functions. This is where I got this very, very long recursion, and at some point I just made them inline, and I actually seen my code like growing a lot, and it can be a lot if you use inline functions many times. This is more common concern.
And back, for example, with Fibonacci numbers, is it example from your book?
Which one?
With Fibonacci numbers.
Yeah, it is in the book.
Yeah, and why is it implemented in recursive way? Because now we have overhead because of recursion, not in iterative way. Yeah, previous slide. No, next. Yeah. Why it's in the recursive way and not an iterative way? Why is it not a for loop?
So the question is where is the Fibonacci iterative?
Yeah, no, why it's not implemented in iterative way?
Oh, it can be. It's just an example. So this is a classic example shown when the concepts of functional programming are shown. One of them is caching, and I think I was initially inspired by the course made by Marcin, functional programming in Scala. So yeah, Fibonacci can be solved in a different way. It can be in an iterative way. Yeah, but whenever you use it later, it's immediate. So maybe we have a case where we use it many times,